can find that quickly because it'd be good if I showed you the formulas for
Uh,
that.
oh, will you get one on the test?
Okay, but you don't have it. You don't have it ahead of time.
Let me see here.
See if you can download that and send it over to me because it really will help here because there's a number of ways that I can show you this, but it may just be a formula that you're given.
Um, yeah, I'm not sure. I'll look and know
Okay,
like
that's okay. So,
more.
so we need another column here. We have to take x and multiply times f. So this is 0, this is 900, this is 1,000, and this is 1,200. Okay,
Okay.
and then you've got to add them all up. So this ends up being 3,100. So to find your expected value of x, you take your x times f. Okay,
Okay.
and it's really a sum. So you're adding these up, and then you're dividing by f. So in this case, it's 3,100 divided by 2,500,
Uh-huh.
and that is your answer. Now the decimal answers here are like 1.5 and a few other ones. So you do have to grab your calculator there, and so here, let me snip those in. All right, so 31 over 25, 1.24, like that.
Okay.
Any questions on that?
That's all.
All right. So I'm just going to go in order, which may or may not be good because it's like these are very different than what you might, we've done them in sort of an order where it's like, okay, here's a normal distribution problem. Here's another
Yeah.
one. Here's another one. It won't be like that on the test. Okay, the time it takes to travel from home to the office is normally distributed with mean 25 and sigma 5. What is the probability that the trip takes between 20 and 30 minutes? This is the probability that x is between 20 and 30. All right,
Okay.
u is 25, sigma is 5. Any idea how we did problems like this when they were normally distributed from before?
Yeah, we took the lower and
That's
the
right.
upper.
This is a normal CDF problem. And so the lower is 20, the upper is 30, and the mean is 25, and the sigma is 5. And you don't have any access to a calculator today to do this.
I have the virtual one.
Okay. It's yeah, it's a little cumbersome to use if you're not used to it. This one, because it's within one standard deviation, ends up being this nice value.
Okay.
But
I remember how to do all the
that's
normal
good. Yeah,
steps and all
that's
that.
really good. That's really good. So the exam is probably not as intensive calculation wise as say the
Uh-huh.
homework, but yeah, there will be some
Yeah,
calculations.
he warned us saying that the homework's going to be way more challenging than all the tests.
Yeah.
So,
All right. So the sample size needed to provide a margin of error of 3 or less with a 0.95 probability when the population standard deviation equals 11 is, this is another formula. This is another one of those like where if I had that sheet, I could just copy it in so you could see it. So the way this formula goes is it's Z alpha divided by 2 times sigma over your margin of error squared, and then you always round up.
okay.
Okay. So just looking at it, it's either going to be 52 or 11, just because you always round up and this that way. But I shouldn't do that, but that's kind of one of these things that I see one of
Mhm.
these problems. So your Z alpha divided by 2 comes from this confidence level. Okay. C is 0.95. Alpha is 1 minus C. Alpha divided by 2 means to divide this number by 2, which is 0.025. So sometimes on your sheets you get a table with these confidence levels in there,
Uh-huh.
and you have to be able to figure out this value or from a table. So I don't think we've done this, but I can sort of talk you through it.
Okay.
So there's it's normal CDF again, but it's the undoing it because this is the area. So
Mhm.
there's this like inverse CDF, and I guess I could show you that. Do you want me to show you on the calculator, or
Yeah,
do you
that's
want
fine.
wait until? Okay, let me pull it up here.
Whatever's easier for you.
Well, I can give you the number, but I mean that doesn't help you on the test. I want you to know how to do it. But if you just want the number right now, I can give you
Yeah,
the.
I'll just take the number then.
Okay, so let me go to a different thing here to calculate it. Um, this is Q norm. So this ends up being 1.96. Okay, and so we need that value for this part of it right here. The
Okay.
margin of error is 3, and sigma is 11. Okay, so this is 1.96 times 11 divided by 3 squared, and then you round up. All right, so if you're trying to follow along there, you want to multiply first, then divide, then square, like that. All right, so this ends up being 51.648. So that rounds up to 52.
Okay. Mhm.
All right, 8.
Number 8, right?
Yeah, 6,
Okay.
7 is not numerical. I mean, you can always cover it, but all right. So X is normally distributed with a mean of 24. That's mu, standard deviation of 6. And we want the probability that X is less than 11.5. So what kind of a problem is this? What have we been doing?
A normal CDF.
Yes, it's your normal CDF. Your lower is unknown. Your upper is 11.5. Do you remember what we put in the lower when we didn't know?
Yeah, the 10 to the 99 or
Negative,
negative.
negative 10 to the 99. Yeah. And they know that you might put the wrong number in here. So I mean, I don't know how, you know, difficult your instructor would be, but that's pretty cruel, but just be careful there with
Okay.
that. 24 and then 6. So I need to get up a normal distribution calculator. I don't like using the virtual one. It's a little cumbersome to use, but
Yeah.
when the student says, "Hey, this is what I got," I go do it. So let me go grab something I like. Me.
That's good.
All right, so we got stat calculators normal. All right, so you said mean of 24, standard deviation of 6, and we want less than 11.5, and we'll compute that. So that becomes, it ends up being this last one here. So let me actually snip in a picture of that so you can see it
Okay.
in case you want to look at it later on. There's a million of these calculators out there. I just happened to find this one. Okay, moving on to, let's see here, number 9. Number 9 here. All right, population has a standard deviation of 16. If a sample size of 64 is selected from this population, what is the probability that a sample mean will be within plus or minus 2 of the population mean? So this is again, it's a normal CDF, but the problem is we don't know like the upper and the lower, the lower and the upper. Okay, which is bad. Like normally we're given those, and then we put in the standard deviation of six. I'm sorry, the mean right here, which we don't have, and the standard deviation, which we kind of have, which you have to divide by the square root of n. So this one does require you to calculate z values. So your z is x minus mu over sigma divided by the square root of n. But this time, they're not even giving you x and mu. They're saying plus or minus 2. So that means that for the first one, it's -2 on the top. And for the second one, it's +2.
Okay.
So that's what x minus mu means. Like let's say mu is 50. It's like saying 48 to 50. Okay, but we don't know, and we don't want to make that jump to conclusions on that. The standard deviation is 16, but it's divided by the square root of 64. Same thing over here. Divided by the square root of 64. So this square root of 64 is 8. 16 divided by 8 is 2. This becomes -2 divided by 2, which is -1. And then this one is also 2 divided by 2, which is +1. So on the z, like the z normal distribution here, you're going from -1 to 1 with a mean of 0. So now you can use normal CDF because you now have a lower, you have an upper, you have a mean, and a standard deviation. This is your mu and this is sigma. So what you have to remember is when you convert your z always has a mu of 0 and a sigma of 1 when you use your z values.
Okay.
All right, so if you dump that into the calculator, it ends up being a known value. There's always a known amount between the first two standard deviations, and that is 0.6826.
Okay, sounds good.
Just a moment here. All right, so next question here, number 10. Number 10. All right, in order to estimate the average time per student on the computer terminals at a local university, data were collected for a sample of 64 business students. That's n equals 64 over a 1 week period. Assume the population standard deviation is 1.6, that's sigma. If the sample mean is 9, okay, so that's something else. The confidence interval is blank hours. Okay. We have not done any confidence intervals. Okay. And it's probably a formula. So the confidence interval is x bar plus or minus z alpha divided by 2 times sigma divided by the square root of n. Okay. Your calculator will also do a confidence interval for you. So I probably should show you that. Is that what you would like?
Yeah.
Okay. All right. So let me go grab that. All right. So let me new share that. All right. So we got, we're going to stat test. Let me see if this will do it. Yes, it will. So z interval here. All right, so notice it says data and stats. Data is if you put your data into list. We're going to go stats here. So notice it asks you for stuff that we already have. It's 1.6. Your X bar is 9, and your sample size is 64. It wants a 95% confidence interval, so that's the 0.95, and then you just calculate.
Okay.
All right, so let me grab a snip of this in case you want to look at that later. Actually tell you where to go. That was stat calc z interval. And it's this right here. All right, so let's go ahead and hit enter. And there it is. So 8.608 to 3.932. I'll snip that in. We'll go back to the screen. I mean, it's really nice. I mean, it does the work for you if you know where to go.
Yeah.
Like if you know which tool to pull from your toolbox, obviously it really can be a lot easier. So I'm going to go back to the other screen there. And you can see that it is this third one there. Any questions on that before we move on to any problem?
Well, that's good.
Okay. All right, number 11. So there's 40 of these. We're coming up on kind of halfway through the lesson here. Good chance for you to decide if we should switch, keep going, whatever you want here.
Yeah, we can just keep going. We can skip
right.
those if you want.
Say that again.
I said we can skip those if you want.
This one, you mean skip 11?
No, like skip the last problems or the last problem.
Okay. So
if there's any other ones like it.
Okay, yeah. We'll see here. So a professor at a local university noted the exam grades of her students were normally distributed with a mean of 73, standard deviation of 11. The professor has informed us that 8.75% of her students received grades of A. What is the minimum score needed to receive a grade of A? All right. So this one's different than any one that we've done. What they're saying is that in the right tail of this distribution is 8.75%. If you want an area, you divide that by 100. So it's 0.08775. Okay, is that all right? Clear?
Yeah.
So there's a couple of ways to do this. One is to use the calculator to let it sort of force that number come out. You can also kind of back into it with these numbers. Like you could try each of these and see which one works out by doing a normal CDF. Mm-hmm. So like, let's say on a test, you're like, well, you weren't really sure what to do. If you did like a normal CDF of say like 95 to 10 to the 99, and your mean is 73 and your standard deviation is 11, if it gives you 0.0875, you've got it.
Uh-huh.
But if that didn't work, you'd have to change this 95 to one of these other ones. That's kind of like the working backwards approach to this.
Okay.
Now, if you don't like that, we can do it another way. What do you think you would do on the test here?
I'm not sure.
Okay, well, I mean, you're the one taking the test here. Like I'm trying to help you out here as much as I can. Like you got to give me a little bit of effort here tonight.
Which way is the easiest, you think?
Like you will always get the right answer if you try all of them and you know what to do. Okay.
Okay.
But I don't know if that's like your approach. I don't know if your approach is like, yeah, I'm gonna just try these until they work. Okay.
Okay.
The other option,
I do that.
Okay. So, this is where it would be good to practice this. Now, if you don't get the right answer, it's like, well, then what do you do? That's why I got to be really clear on what we're doing here, which is because the area is 0.0875. That's why we can do this and hope that it works. So I'll go back to that other calculator and get you the answer here. Let me do that. So one of the nice things about this calculator is I can actually feed it the mean, just like on the TI, give it the standard deviation. But this time I can actually just put in the area and it'll work backwards for me. But you don't have that tool on your test. That's why it's like,
yeah,
doesn't really seem fair. But just let me snip that in here so you can see. All right, so you can see here that like the answer is 87.92 because it gives you an area of 0.0875 in the tail there. As you're very careful, like you would check this, be like, okay, didn't work. Okay, it did work. And maybe that's okay. Do you have enough time on the exam to do that? That's something to think about.
Yeah. I mean, last exam I left pretty early, so
Okay. And this is in person or is it
yeah,
online? Online in person.
they're in person.
Okay. Like a paper test.
They are.
Okay. All right. So let's go take a look at this one here. This one looks a lot like one of the earlier ones that we did. You remember the coffee and then the frequency. This one's no longer a frequency, it's a probability. Okay. So
Okay.
all the probabilities have to add up to one. Okay. And they do, but that's just something to maybe check. We're asked for the probability that in a given game, the Lions do not score more than 2 goals. So I always hate that word not. I don't like seeing it and I always ignore it. I say, well, what if it didn't? What is the probability that the Lions score more than 2 goals? That's greater than 2. And then I know that if I really want the other direction, it's 1 minus the probability that X is greater than 2. Okay.
Mm-hmm.
So greater than 2 does not include 2. Greater than 2 includes 3 and 4. Okay. So we're basically asking for the sum of those two probabilities.
Mm-hmm.
So we're just adding up those numbers, 0.3 and 0.15. And that's 0.445 there. Okay.
Okay.
But because we want the not is this one down here. So you have to take 1 minus that value. And that is your final answer.
Okay, thank you. Mm.
So nice enough that they didn't actually put in the 0.45. I probably would have just to see if you would choose the wrong number. But yeah, like you gotta be very careful. It's very distinguish between the two of them.
Yeah.
All right, new problem here. Number 14. All right, it is known that the population variance equals 529. That's sigma squared, okay? With a 95% probability, that's C, the sample size that needs to be taken if the desired margin of error is 4 or less, margin of error equals 4. So your sample size formula, we did this earlier, is Z alpha over 2 times sigma over margin of error squared. Okay, same formula as earlier. You always round up. Okay.
Okay.
Now, okay, they're giving you sigma squared. You don't want to use 529. You want to take the square root of that. But then you're squaring it again. So it actually undoes it. So sometimes the formulas are listed like this in your whatever they give you on the exam, your formula sheet. That's one of the reasons why I would like to have it just to always pull in the same one each time so you can see it. Now you just use this number. Like sigma squared is 529. So you just replace that with 529. The Z alpha over 2, similar to how we did earlier, it is 1.96. Margin of error is 4. So it's C is 0.95. Z of alpha over 2 that this comes from is 1.96. So it's 1.96 squared times 529 divided by 4 squared. And because you're rounding up, you can see why the answer is like 509, 508. Well, one of them's probably, the answer is probably like 508.5 or 127.5. And you got to remember to round it up. You always round it up regardless of what number you see. All right, so let me see if I can get this calculation for you. Let's see here, we got this. $529 over that. All right, so yeah,
I
so
got
this one,
a weird number.
so I get this, it ends up being 127 0.0129. And that's why 127 is there. Like teacher wants you to think that, oh, it rounds to 127. No, it always rounds up, rounds up. Now, if you got a weird number, I mean, if you're not using the right tool, it just won't happen.
Yeah, that's probably what it is.
It's not going to help. All right. All right, so looking ahead here, I'm just going to scroll through a few of these problems just to kind of see what else you have. All right, a lot of the same. I mean, it's kind of like, I would say 2/3 of it's numerical, a third is just sort of other questions. So you got to know how to do these calculations. You got to be comfortable doing everything we've been doing today or more. All right, let's take a look at 15 here. All right, population has a mean of 180 and a standard deviation of 36. Sample of 84 observations will be taken. The probability that the sample mean will be between 181 and 185 is. So what kind of question do you think that this is here? How would we do this based on what we've been doing today?
Would you do it the normal CDF?
Yes. Ton of normal CDFs. Do they give you the lower in this problem?
Is it 84?
84 is the samples, number of samples.
I'm not sure which one it is.
Okay, so this is the mean. Mu is 180. Between.
Oh, okay.
So between gives you the lower and the upper. So 181, 185, mu of 180. Standard deviation is 36. So you have to divide that though by the square root of 84. If you forget to divide by the square root of n, so sigma is the sigma divided square root of n. If you forget to do that, it will likely be there. Like you likely will have, they'll be that close. I mean, it's not fair, but that is the way it goes. So let me go grab this other calculator here. So we said this is a between. So mean of 180, standard deviation of 36 divided by the square root of 84. Got that. And then we're going 181 to 185. Let's compute that. There it is. Okay. Grab a snip of this so you can see again what's going on here. So it's between 181 and 185. You get the, I mean, your calculator will be the same, 0.2989. It should match up like really, really good. Sorry, 2980. I almost chose the wrong one. There, you shouldn't have to sort of fudge it or like nudge it. It should really just be exact.
Okay.
A lot of times students think, oh, well, if it's close enough, it's not. You've made a mistake, unfortunately.
Yeah.
All right, let's do number 16. All right, random sample of 100,000 credit sales in a department store showed an average sale of 87.25. This is X bar. From past data, it is known that the standard deviation of the population sigma is 20. What is the 95% confidence interval of the population mean? So you have a formula for this, but you can also go and use your calculator. And that's what I recommend that we do here. If you remember earlier here, I went back to this earlier problem here. You're going to go to stat calc z interval. Okay. The reason it's a z interval is because you know the population standard deviation, you know that sigma is there. So you need sigma, x bar, n, and c. You have all of those. All right. So let's go. Let's go back to the calculator on that one here and take a look at that. All right, turn it back on. Clear. So stat, test, all these different ones. You got to know which one to use. Z interval, intervals for confidence intervals. It's really what it stands for. Stats, because we don't have the data. Sigma is 20. X bar is 87.25. And it's quite large. This might be an issue. I'm going to check here. 1, 2, 3. And we want the 95% confidence interval. Okay, so we're going to calculate that. All right, so we get 86 point. Did I not put this in? I feel like I didn't write this in correctly. 10. Oh, I have the wrong n. So my n is wrong.
Oh, okay.
That's why I didn't like it. So if you see it doesn't match up, it's because you know, in this case, Matthew made a mistake. So I got to go and fix that here. Boom. All right, 87.126 or 87.13 to 87.37 there. So let me grab a snip of that in case you want to look at that later. Let me go back to the other screen. I'd recommend redoing these calculations just because you're going to be doing it on the exam.
Yeah.
Where you know where everything is. Nothing worse than getting there and not knowing what to do. All right, just last snip. Okay, let me go back to the other screen. All right. So that's it's letter A there.
Yeah.
All right, so 18 here. Consider the probability distribution below. The variance of X equals. Now, I think it might have been the case at one time that the calculator will actually do this one, but I don't remember. And I don't know if we want to spend the time looking. Otherwise, you got to use formulas, which isn't great, but it is the only way here. Yeah, I'm not saying it. Okay. To find the variance, you first need the expected value of X. So the expected value of X is the summation of X times f of X over, I'm sorry, just that. Sorry, it's just the summation of X times f of X. So you have to make a new column here where you multiply these together. So you got 10 times 0.2, that's 2, 20 times 0.4, which is 8, 30 times 0.3, which is 9, 40 times 0.1, which is 4, and you add these up and you get 23. So that's the first thing you need. Second thing you need is what's called the expected value of X squared. So this is a little bit more difficult. You might find it's worth making a new column here. You have to square X. So you got 100, 400, 900, 1600, and then you have to multiply it by f of X. It's X squared times f of X. So you have to take 100 multiplied by 0.2, which is 20. 400 times 0.4 is 160. 900 times 0.3 is 270. 1600 times 0.1 is 160. And then you add all these up. You add them all up. Again, that's what the sigma means. Sigma means add them all up. This is on your formula sheet. It might not be written out as succinctly as this, like it may just be a mesh of formulas, but you do them in this order. So we are 320 plus 290. What is that? 610 maybe? And you're like, wait, we're doing variance. Yeah, we're doing variance. So this leads to variance. So variance is expected value of X squared. So the number you just calculated minus the expected value of X, but it's squared. It should always be the case that the first number is larger than the second number. So like if you get a negative number out of this, you've done something wrong.
Uh-huh.
And believe it or not, that happens because you're just, test is stressful and you
Trying to fly
think,
through it.
yeah, you're trying to fly through it. You got other things on your mind. So this one ends up being 81. You'll notice that some of those other numbers that we got are there. So make sure your answer is what it's actually asking for, not just the first number you see. If you ever taken standardized tests or anything in college, they do that as well. All right, looks like we move on to 20. All right. Production process produces 3% defective parts. Sample of 5 parts from the production process is selected. What is the probability that the sample contains exactly, that's very important, exactly 2 defective parts? This is the probability that X equals 2. The number that you're sampling is 5, and the probability of defective is 0.03. Any idea what kind of distribution this is? There's 2 outcomes, defective or not defective.
I'd have to look.
So this is a binomial distribution.
Okay.
Okay, so what you're looking for with binomial is 2 potential outcomes, either success or failure. They usually give you the probability here as a percentage or decimal. They give you a fixed sample size. They don't say that you can sample forever. They just say it's like I sample 5 people, 10 people, 5 parts here. And this is very important. It's either going to say exactly a number, less than a number, greater than a number, at most a number, at least a number, and so on. Because that tells you, because there's 2 binomial distributions that you can use in the calculator. There's binom PDF, which is what we're going to use here because it's exact, and there's binom CDF, which is when you use when it's greater than or less than or greater than or equal to or less than or equal to. So use them for these different cases. All right, so we will be going to the calculator. All right, so this time you're going to second distribution. I'll write this down, second distribution, and go down. Binom, see how there's PDF and CDF? Are you seeing that?
Mm-hmm.
Okay. You got to choose the right one because the answer might be there from the wrong ones. This is a PDF. You don't need to know why. Now, unfortunately, mine doesn't give you, darn it, why doesn't it doesn't give me the list of what it needs.
Oh yeah.
So let me go, I gotta go check the internet for that. TI-83 binom CDF. Okay, NPX value. Okay, so I'll write this down here. NPX value. Okay. So the number of trials here is 5, comma. The P value is 0.03, comma, and the X value you care about is 2. And you get 0.0082. And you'll see that that is on the list there. So let me snip this screen in so you can see it. All right. Let me go back to that so you can see that. All right, so just like I said, you get a second distribution, binom PDF, NP and X. N is 5, P is 0.03, X is 2, and you see that that number is there. You do not want to try and do this by hand. It will not work out very well most of the time. All right. So I'm just looking here to see if there's any more binomial distribution problems, because it's odd that they just sort of threw one in there. Wow, that does look to be the only one. Are you sure you guys did binomial distribution? Seems like, I guess the last one is, but okay. All right, so here we go. 21 here. All right, so they give you X and they give you P of X here. And it's some scenario, but you don't really care what the scenario is. You just need to know that it's X and P of X. Variance is, so this one asks for the variance. So variance requires you to find the expected value of X, which is X times P of X. And then you also need to do X squared times P of X. Ah, boy. This is really cumbersome to do by hand. The calculator is also kind of a pain because you got to put list 1 and list 2. So I guess that's the right way to do it. We don't have enough time to do this though. So let me go find another problem here for us to look at. So we can certainly do this one tomorrow. Let me go to 24. All right, so 24 here. Random samples of size 64 are taken from an infinite population whose mean and standard deviation are 240 and 16. So that's the mean. That's mu because it's a population, and sigma for the standard deviation. The distribution of the population is unknown. The mean and standard error of the mean are. So the mean is always the mean. Okay, the mean is always the mean. That means your mean is always 240. That never changed. But the sigma changes because it's sigma divided by the square root of n. So in this problem, it's 16 divided by the square root of 64 because that is your sample size there. 16 divided by 8 or 2. All right. Just quickly talk you through maybe 27 here. Maybe you can do it later on a calculator. So we got 27 here. We got another 95% confidence interval. So you're going to want to go to the Z interval in the calculator here. X bar ends up being 1400. Sigma is 240 and a sample size of 64. So you want to use the calculator for this one. This would be a good one for you to try on your own and see where you're at with that. All right, well, that does take us into the end of our lesson.